In last class, we saw GRE tunnel. DMVPN is also a GRE tunnel. What is the connection? Both are GRE. What is the difference? That is point-to-point GRE. This is multi-point GRE. That is the big difference. I repeat. Simply, GRE is a point-to-point. For example, if I need to form tunnel between the three sides from the hub, GRE, you need to form three tunnels. Interface tunnel 0 with this one. Interface tunnel 1 with this one. Interface tunnel 2 with this one. I'll call this as spokes 1, spokes 2, spokes 3. Are you listening? Right. So you have multiple tunnels, multiple session, multiplied bandwidth, multiplied CPU. To avoid this, we introduce DMVPN, which is multi-point GRE. Is a multi-point GRE. You have one interface, tunnel interface, and you're going to have multiple spokes negotiated. And how many tunnel sessions on the hub? Only one. Not only that, in the normal GRE, if you put three tunnels, communication between these two will be like this. Will be like this, always via hub. Whereas in this DMVPN, there is one protocol called NHRP. NHRP. What this protocol will do, will resolve the private IP address of the spokes so that switch 2 will know, spokes 2 will know on which public address the spokes 1 is. So it can just communicate like this. I want to repeat this again. DMVPN is not only a multi-point GRE, it also helps spokes to spokes direct communication, for which you no need to do any configuration other than this protocol NHRP in DMVPN. Spokes 2, you are not going to say spokes 1 and spokes 3 info. You are not going to say that. But when someone from spokes 2 wants to ping someone in spokes 1, using NHRP, from hub, spokes 2 will know about spokes 1. After knowing about spokes 1, it goes directly. I showed you yesterday in the tunnel there is a private IP address. This NHRP, what it will do, it will resolve the private IP address of S1. S2 knows the public IP address of S1. Everyone knows the public IP address of the other spokes. But in order to use the tunnel, in order to go like this, they need to know the private address of the tunnel, which is what resolved using NHRP. You know very well they encapsulate the inner header and have the outer header. The outer header and inner header. The inner header private IP address only known to S2 and S1 and S3. So if I need to go to S1, which public address I should go? S2 should know that. In order to go to S1, which public IP address? Where is that S1? S1 is in this public IP address. So in order to go to the private IP address of S1, you need to go to J. How S2 knows that? Given by NHRP. How NHRP knows that? Because hub knows J, S1, K, S2, L, S3. Hub will know about all spokes. Now I want to repeat the story. DMVPN is multi-point GRE. You no need to create multiple tunnels, you just got only one tunnel with which you can have multiple spokes on the other end. Not only this, with the help of DMVPN, you can now have tunnel between spokes for which you no need to do any configuration. Spokes will know about the other spokes from hub. How hub knows? Every spoke will go and register with the hub. So hub knows who is where. Now using NHRP, hub learned all the spokes, their public and private address. Now if spokes 2 wants to go to spokes 1 private network, it asks NHRP, and NHRP downloads that information from the hub saying for this private IP address, this is the public address. So now knowing the public address of S1, router S2 looks into the routing table and directly talks to S1 because it knows the public IP address of S1. It forms the tunnel between spokes directly. So the communication is not always through the hub. It's straight between spokes to spokes. And this magic is done by the protocol called Next Hop Resolution Protocol, NHRP. So let me restart the story in a different angle. You have a hub. Hub has got only one tunnel interface. And it is going to form tunnel with multiple endpoints depending on the number of spokes. Now all the spokes will come and talk to the hub saying, I'm your spokes. This is my public IP address. This is my private IP address. Using NHRP, S1, S2, S3 gives their information to the hub. Hub maintains a table called NHRP mapping table. In that table, it knows all the spokes public and their tunnel IP address, which is private. That is more than enough for all the spokes to communicate to the hub and hub to communicate back to spokes. But the additional advantage is even spokes to spokes is possible without reconfiguring other spokes as a peer of the tunnel. You don't need to configure a tunnel between S1 and S2. They themselves will form tunnel by learning whom we are talking They go and negotiate and bring the tunnel up between the spokes, and the traffics are routed through the internet, not always through the hub. Knowing the other spokes is a miraculous magic. If alpha is pinging beta, spokes 2 will automatically learn using NHRP the location of beta. Beta is a private network of S1. To go to the private network, you need to go to this J public, which is learned dynamically via the protocol NHRP. And those informations are downloaded from hub. And they will have tunnel only when there is some traffic to send. Once the traffic is sent, the tunnel will be teared off. It will be removed. And only whenever there is a need for communication, the tunnel will dynamically come up. This all will save CPU. You don't need to maintain session for tunnels when there is no traffic. So, as the word says, dynamic multi-point VPN. This is a tunnel that is established dynamically, not just one-to-one, with multiple points. Dynamic multi-point VPN, which uses a protocol called MGRE or multi-point GRE. Multi-point GRE comes with NHRP, next stop resolution protocol. Is there any question? Hmm. Hmm. See, let me repeat. Hub don't know any spokes initially, but we will configure all spokes with hub information. So spokes will go to hub and enroll as a spokes with the hub. So now hub starts learning the spokes with which the tunnel need to be established whenever there is a communication initiated. If no communication, no tunnel. Now, hub knows all the spokes because all the spokes, they voluntarily come and enroll, register with the hub. These informations are collected by this protocol NHRP and it maintains the table. The table that has got the tunnel IP address, which is a private IP address of all the spokes, and the public address from where they are talking, where they came to register. So the NHRP table have got the clear information about the other spokes. NHRP has maintained all the spokes information. Now, if any spokes want to talk to other spokes, they need a tunnel. But we are not going to configure any tunnel in between the spokes. We are not even going to say about other tunnels, other spokes to spokes. We will not be talking about other spokes to the spokes. But you want to communicate between two spokes. So if I say you want to communicate between two spokes, what does that mean? You want to talk from alpha to beta. Now, S2 should know where is beta so that it can go and negotiate tunnel. For that, it goes to the hub and requests for the beta information. Hub knows beta. Hub will say it is this public IP address S1. You go there, you will find beta. S2 knows S1 very well. S2 public have got reachability to S1 public IP address. Is that true or not? Yes or no? They are connected to the internet cloud. Can S2 ping S1? Can S1 ping S2? Yeah. So now it will go to S1 and say, I would like to form a tunnel with you. And S1, checking its NHRP map table, understands, yes, I can form tunnel with S2 because S2 is also an NHRP member. Both S1 and S2 have downloaded the table now. So they know each other. They can see themselves in the table. So S1 also agrees to form tunnel. And they communicate. When they communicate, they talk directly to their public IP address and decapsulated and then goes to the private. There is no need to go through hub because through NHRP they have already learned, resolved the public IP address. Is this clear? All right. Now, the explanations what I gave are very clearly given to you here. You can go through this later. Now, this is a sample configuration of a hub. You see, this part you know very well. Last class we did GRE. We gave an IP address for the tunnel. And we gave the source interface or IP address. You remember? You can give IP address of your exit interface, the WAN interface, or you can give what? IP address of your exit interface. But because this is multi-point, you will not know who the destination is. Hub will not know the destination. Why? Hub will dynamically learn the destinations. When spokes come and register, only then hub will know who the destination is. Do you agree? So there is no destination. And tunnel mode, some operating system will have DMVPN, some operating system will have multi-point GRE. Multi-point GRE. That is the tunnel mode. Either this command or that command will be there. According to my knowledge, our operating system in GNS3 will have this command. But in some high-end devices, you will have straight away DMVPN as the command. Tunnel key is to identify the tunnel because you're going to have multi-point. It's not one point on the other end. So they will all should have one key in order to form a group of tunnel endpoint. So tunnel key is must. This is not a password. This is key to identify. And then IP NHRP map multicast dynamic. This is the command that you should say if you are going to use some routing protocols to share the routes via the tunnel. All routing protocol use what? Multicasting. So when a hello packet comes from OSPF, they are using OSPF here. So this will dynamically learn the spokes and all the spokes multicast communications. Whereas on the spokes, you won't say dynamic. In the spokes, you will say the multicast traffic should go to the hub. I think you understand what I'm trying to say. Hub have to learn every spokes dynamically. So the word dynamically you should put. Whereas on the spokes router configuration, if you see the same command, you see, when you say destination, all multicast, everything will go to that destination. This is the IP address of the hub router. All the multicast traffics will go to that address. And let's go back up. This ID, you can give any number, but it should be again same on all the routers. Same like this ID. But this is for the tunnel. This is for the NHRP protocol. NHRP protocol to know that all these are same group members, all the spokes belong to me, this ID is used. You can put any number. This need not to be this 5-digit number. It can also be 1. Right? And only on the hub, not only on the hub, we also type this, but with the public IP address of the hub, we will type on the spokes. On the hub, you say this command, IP, NHRP, next stop self, or next stop server. Who is the server for NHRP? Hub is the server, isn't it? Everyone comes and registers. So this is saying this address is the server's address. Next stop server. So anything that NHRP members want to query, they will query to this address. Who is this? This is the address of the hub, the tunnel address, the private address of the hub. This is an optional one, hold time 5 minutes. The table will be refreshed after 5 minutes. And then this is an optional one, you are enabling OSPF under the tunnel interface to distribute routes after forming OSPF peer. Okay, this is OSPF. These are all optional. This one is optional. These two are optional. Now, let us go again one more time to understand the configuration. Tunnel interface needs an IP address. And tunnel source should be given. Destination, dynamic. So you don't say any destination. This is mode. This is to identify tunnel key. So simple. These 5 lines should not be a problem for you. IP address, source, destination, anyone, mode, this, key this. Next is for NHRP, because with the help of NHRP only, the learning happens. So NHRP needs one identification, so this is the command to give it. And NHRP needs to accept all the multicast traffic coming from the spokes. So you say dynamic. And then you are saying for NHRP, I am the server. This is the address which is responsible. This is an optional one. And this is OSPF. You know it. Is there any problem in understanding this tunnel configuration on the hub router? Okay. Now let us go to the spokes router. Spokes should come and register with the hub. For that, spokes should know the hub. This one, the tunnel IP address is given, same subnet. There you gave 10.0.0.1. Here you should give same subnet 10.0.0.2. Now, tunnel source, tunnel destination also, IP address of the hub. That's the private IP address of the hub. And now, this one, mode, key, all these things. Now, this is what varies. There you said IP NHRP map, you see there, dynamic. Because it's the hub, you do not know who the spokes is. So when NHRP or any routing protocol uses multicast to communicate, this will dynamically learn them, learn all the spokes info. Whereas here you should say, in order to go to the hub, this destination, you need to go to this address, which is the public IP address. In here, they made a mistake. They should put public IP address, but they have put it. Okay, one is a private IP address. To go to that private IP address of the tunnel, which public IP address I should go? This is the address of the hub. And next is this one, same thing what you gave on the hub, you should give here. Like a key ID for the tunnel, this is ID for the NHRP network. And this one you already saw there. This one you already saw there. So the difference here is this command and this command. The destination is nothing there on the top, whereas here the destination is hub. You see, you're not giving destination as the other spokes. You are giving only the hub. But spokes to spokes is dynamic. You don't need to care about it. NHRP will take care of it. All right. So is there any confusion in these commands? Now let us go to one example. This is also an example only. I have some better example. You see, you have two spokes and one hub. Spokes, hub's public IP address is this. Okay, hub's public IP address is this. It's a private IP address, you and me know, but in this document, that is how they have written. So 192 considered as public. Okay, which is here. This is the tunnel IP address. This is the tunnel IP address. This is another tunnel IP address of these books, which is private. All the 10 are private. Don't forget. So every router has got one public IP address for a GRE to negotiate. Now, you see hub configuration, interface tunnel 0. This is a private IP address. Source, mode, key, destination, multicast dynamic, NHRP ID, and then next up server, NHRP server. I myself, this is an optional one. This is you are consider you want to enable OSPF, you can do it. You can also have EIGRP if you want. Is this clear on the hub router? Almost the same. All right, so configuration on this router is over. Now let us see the configuration on the spokes router. On the spokes router, this is the private IP address, and this is the source from where the tunnel need to be negotiated, which has got a public IP address on it. Mode, this one you know, this one you know. Now this is where the change is. First, you need to say the private and then the public. You are saying, in order to go to the hub 10.0.0.1, you need to go to this public IP address. You remember I told you 192.168 is public. And then this need to be same on all router. We have put it here. And this, is there any confusion in this spokes? That's all. DMVPN. All right. Likewise, you put it in the other spokes. Now we are going to quickly do this lab and see how it works. And this is the command to verify. Show DMVPN or show IP NHRP. Right? And then you can ping between the privates. That's ping test. Shall we go to lab? Wonderful. These routers need to ping first. There is an internet in the middle. I'll use a notepad to configure. And I'm going to use default route and static routes. Is it good to do that? Yeah, why not? So interface on in router 3 is F00 with the IP address 20.0.0. And then IP route, any network, any subnet mask, send the traffic to 20.0.0.4. And or you can also run a routing protocol between R3, R1, R2, or R4. I'm just trying to go with a normal realistic configuration in the real world. Right. On router 3. It's done. And now router 1. Router 1 has got 30.1. And this is 30.4. Router 1. And router 2, I've got 40.2. And this is 40.4. Router 2 is also ready. Now the last router is 4. There's no need for any static routes here. Interface F01. F00 is 24. This is 34. And this is 44. This goes on router 4. That's it. Now I should have reachability between these three routers, R1, R2, and R3. Verify. Ping 30001. The negotiation is going to happen using this address. Done. So we are able to ping all the remote device. R3 is the hub router. Hmm. Did I do? Why you need? R4 is connected to all these three networks directly. Why you need to write any route? No necessary. Now we will start the DMVPN configuration. On R3, interface tunnel 0. IP address, I'm giving a private IP address 10.0.0.1. Sorry, on hub I'm going to say 3 and 255.0.0.0. Whereas on these books, interface tunnel 0, IP address is 10.0.0.1, 255.0.0.0. And then on the other spokes, interface tunnel 0, IP address 10.0.0.2. Done. And then the tunnel source. Tunnel source is my exit interface. And it's the same with all other router. So I'll paste. I'm removing R4 from here, which is not needed anymore. Next. Tunnel mode is multi-point GRE multi-point. You see, you don't have DMVPN command. Okay, DMVPN is also there. Fine, we can use that one also. You can use this one or you can use multi-point GRE. Anything is okay. No, this is not DMVPN. This is sorry, my eyes are not good. Okay, there is no DMVPN, you see. So we have to say this one only. Multi-point GRE multi-point. You see GRE multi-point. Right. This is equal to mode DMVPN. I told you the other operating system will have DMVPN, the high-end operating system. Directly you can say DMVPN, but here you need to say GRE multi-point. Put the same command on all other device. Now, on the hub router, we need to say the tunnel destination. Tunnel destination is null actually, right? Tunnel destination is, you don't need to even mention it, 000, you don't need to say that. We don't have a destination for the hub. So here you should say tunnel destination is, which address you will give? Private address. You remember yesterday you did GRE. Did you give any private IP address for destination? How it will go and negotiate tunnel? It won't. Tunnel destination is 20001. That is where it has to go and negotiate. Tunnel destination configuration failed. Tunnel mode is multi. Tunnel failed in the mode. That is true. You cannot give destination command at all in the mode when it is multi-point GRE. That is true. Then that configuration. The high-end devices may support this command. When DMVPN mode is supported, then this command is supported. But what we have to do here is we have to tell one more command which is missing here. You see here we have tunnel IP address. This is optional authentication. Multicast dynamic, we will give that one. Mode is GRE multi-point. Source is this. We no need to mention the destination. And then NHRP we had to configure. This had to configure. On the hub side we have no problem. Now let's go to the spoke side. Spoke side for this operating system, you have to say tunnel source. That's it. You don't need to worry about the destination because the destination is taken care here. Send all the multicast, that is nothing but destination. Send all the multicast NHRP users, multicast OSP users to this public IP address. This is the command additionally you need to do. So what I'm going to do is I'm going to copy this to the document. I'll send the document to you later. So we don't do this one, we do this one. We do this one. The address is the public IP address. In our case, here in this document, it is 192.168.1.1. This one or this one will be, it depends on the operating system. So, you are not going to worry about the destination now. On this router, we are not focusing on destination. See how nicely it says that it cannot be, you cannot have a destination when it has multi-point GRE. Okay, what is next? Tunnel ID is missing. You see, we need to give a tunnel key. On all the router, you should give the same thing. So let's go to R3 and say tunnel key 1, 2, 3. Give the same thing on all devices. Tunnel key 1, 2, 3. Tunnel key 1, 2, 3. So forget about destination. Only on you don't need to say destination at all in any router. All right. So what else? On the hub router, only now NHRP need to be started. We have done all the other things for hub router using tunnel command. Tunnel source, this one. Protection is that is different. That is IPsec. We are not doing IPsec. We are doing DMVPN. So now we need to start this configuration. This two command, and then you can add OSPF. All right. IP NHRP multicast IP NHRP network ID. Network ID. I'm going to give, I'll not forget if I give the same number which I gave for tunnel 123. Nothing wrong in keeping same. IP NHRP NHS next stop server is dynamic. Or in this version of operating system, do we have that command? The NHS command is not here in this version, but in the document you will find there. Here I'm going to say only the map command. Map all that multicast. Map all the multicast dynamically. Now the equivalent command to this one on the spoke side will have an IP address. On the spoke side, this is the command. Right? On the spokes, this is really not needed. Dynamic is only on the hub. Here we need to give this. IP NHRP multicast. What's the map multicast? Multicast. And I have to specify the IP address of the hub. Wait, I'm in hub. I'm in hub. So here, IP NHRP. Hold on, I did not give NHRP ID. Let us give ID. We gave ID there. Let us do one by one. Break one by one. I gave ID here, right? So that ID should be same on all device. Let me paste that one. Okay. Next is after ID I gave here IP NHRP map multicast dynamic, but here I'm going to say IP NHRP map multicast to 20.0.0. The public IP address, which is one here. Because we give this command, you don't need to say destination. This is telling the spokes where the hub is. This is telling the spokes where the hub is. Now, we also need to map the private to public on the spokes router, like this. IP NHRP. In order to go to 10.0.0.3, you need to go to this public IP address 20.0.0.3. Sorry, 20.0.0.1. Let me check what private IP, what tunnel IP address I've given here. And private IP address of the hub to which we need to negotiate and form tunnels so that encapsulation and decapsulation can happen. So that command is IP NHRP map, same like multicast, but instead of saying multicast, you are going to say to this private IP address, this is the public IP address. So there is two map command in this version of operating system. Whereas in the other version, you don't have two map command. You just got only one. Right. So you need to know the difference between the operating systems also. IP NHRP map, we give the private IP address. What is the IP address that we gave? 10.0.0.1. Oh, no. 3. Yeah, 10.0.0.3. And then the next the public IP address. If you see the command, put question mark, it says the IP address of the destination. What destination? Tunnel destination. You are in the tunnel. So that will be like 10.0.0.3, and then NH means NBMA means public IP address, non-broadcast multi-access address, which is 20.0.0.1. Here also 1, right? 3. But this is 1, correct? Public is 1. All right. So this is also done. Now only the OSPF related things are there, but let's go here and verify whether anything additional needed. This is done. This is done. Okay. We have to say this command only on the hub, but nothing wrong in saying who is the server on the client. So I'm going to give this IP address also, nothing wrong. So there are how many commands of NHRP? 1, 2, 3, 4 command mandate. These 2 are optional. Authentication on this. IP NHRP NHS is 10.0.0.3. Right. That's all. Now what is left is the OSPF. Only if it is needed, we will enable OSPF. Otherwise, that is also not needed. When this is properly configured, you will be able to ping between the tunnels. I'm going to paste the same on this. Looks like some commands are still not configured. NHRP command, we need to have this, no, not this one. We need to have this one. Did I configure that? Yes. And then I need to have this one. Did I configure that? No, that is not there. IP NHRP map multicast. How did I miss it? Oh, it is here. Okay. R2. Okay. Let's quickly verify whether all the commands are present. Show IP, show run, interface tunnel 0. Okay, 4 NHRP commands are there. Whereas in the hub, you will have only 3 NHRP commands. Show, run, interface tunnel 0. What is missing? NHRP ID. Server NHS command is missing. Interface tunnel 0. IP NHRP NHS. Its own address. 10.0.0.3. Let's go verify on the top. The hub router. Multicast dynamic, have we given multicast dynamic? It is given. ID is given. Only 2. So this is also not needed. Only on the server you give. I said opposite. So only on the server you should say who is the NHS. Means who is the server. It is okay if it is there. Nothing wrong. Nothing wrong. I just did this because in this document they mentioned we need to put it in the hub also. That is for iOS X. Even iOS X. That's not needed. No need to do this in the hub router. It's waste. So these are the 2 main commands NHRP. And the tunnel commands are source, key, mode. Source, key, mode. Perfect. Nothing more is needed here. On the spokes, source, key, mode. That's all even here. So let's go and verify whether those things are there. Not necessary. That is default. No need to worry about it. It won't redirect because it is DMVPN. They themselves will find the route and go. So by default, it won't redirect to someone like an intermediate proxy. Show run interface tunnel 0. Right. I did not configure this. It is by default, so no worries. That's for security. It is there. Okay. Tunnel source, tunnel mode, tunnel key, 3 commands. Perfect. Now DMVPN should be working. Show IP, show DMVPN. Yes, it says it is up. It is up. And that is later. Nothing will be there. Only after communication, they dynamically learn. Here you will have show IP and HRP. Here, let's say show DMVPN. You have two. Very nice. And next is show IP and HRP. You will see two registration coming from one from the spokes saying my public IP address is this. Coming from other spokes, my public IP address is this. But you won't find this. You will find only one on the spokes. This is the hub. The other spokes will come only when you try pinging. Ping the other spokes 10.0.0. Where's the other spokes? 1. See, you're able to ping now. If you check now, you will see that. How is this magic happen? It was learned. It got downloaded from the hub dynamically. Now, if you trace route, they go straight away. They don't need to go via. They don't need to go via. They don't need to go via the hub. They go straight. I'm in R1. You see, it goes. What is this? Is it going through the hub? Yes, this is hub. Yeah, go straight now. You see, it goes straight. It has formed tunnel, direct tunnel. It no need to go through the hub. Right? So you do and see, then you will be more comfortable. Let's